4, solving exponential inequalities. Well, really, we can just treat it like an equal sign. As long as the bases are the same, then the exponents we can set equal to each other, except for now we don't set equal to each other, we just set less than, right? And the only time it really flips or changes is when we multiply or divide by negative. So basically we need the bases to be the same, but there's no way I can rewrite 6 as something, 6 raised to something and 5 raised to something getting the same base, right? So what we do on these, there's some steps I'll write down. But when you're solving these or inequalities, equal sign or an inequality, step 1 is to basically get the one base on each side. And once you have one base on each side of the inequality or the equal sign, then you can take the log of both sides. So then take log of both sides, and you can take the common log. Okay, so I just take log 6 raised to 2 minus 5 is less than, or you can put an equal sign for now, it doesn't matter. Log 5 raised to 3y. And then we just use our rules of exponents. So step 2, bring down the exponent. So bring that exponent down and multiply it by the log. And make sure you put that in parentheses. So when I'm bringing this 2y to the, when I'm bringing this 2y to the front, 2y to the negative 5, I put that in parentheses because that's being multiplied by the log base 6. And then bring down this 3y, and that's being multiplied by log 5. Sorry, that's just log 6, not base 6. So just log 6 there. Alright, so once you do that, then sometimes you might have to distribute. So step 3 might be to distribute. So distribute the log of whatever it is. So you can distribute log of something, but you can't distribute like the letters log into something. So this has got to go into both. So I have 2y times log 6 minus 5 log 6 less than 3 times y, because there's no addition or subtraction, so it's just 3y log 6. Okay, step 4 is to get the variable on it by itself. By itself. So that means my variable is y, so that's attached to that log, and this is attached to that log. So I'm going to get that y on one side of the equal sign or the inequality, right? So I'm going to go ahead and, so I don't have to deal with negatives. I'm going to subtract this one later on. I won't have to deal with negatives, so I'm going to subtract that one. And I can't subtract these because they're two different logs, right? Even though they have the same base. So I could actually use another property, but I can just leave them like this. So negative 5 log 6 is less than 3y times log 5 minus 2y log 6. Log 6. Okay, and then once I get the log by itself, then I factor out. So step 5 would be factor out variable, because these two terms have a y in it, and those y's are being multiplied by logs, so I can factor out a y. So it's y on the outside, 3 log 5 minus 2 log 6. Put that in parentheses. Less than or equal to negative 5 log 6. And now, last step, step 6, is just to divide by whatever's not the variable. divide by what is not the variable. And maybe that doesn't make sense, but maybe you'll see it now because this is being times, so by all of this, right? But that all of that is not y, so that's what I'm going to divide by. And then here you just got to be careful on your calculator because whenever you hit the log button, it'll automatically bring up a parenthesis, so then you have to close that parenthesis off. And then I would just make sure to hit on your graphing calculator, depending on which one you have. That alpha link does the fraction bar, so it automatically does this fraction for you. And you can just do -5 log 6. Make sure you close that parenthesis. Then go on the bottom of your fraction bar, put 3 log. As soon as you hit the log, do the parenthesis, close that one off, then subtract 2. When you hit this log, it'll do parentheses, so make sure you close that one off. And then go ahead and hit enter. And so we get -7.1970 y, and so if that's an equal sign, it's just equals, but because we divided by a negative right there, and when we divided, it's actually going to flip that direction of that sign. Actually, no, that part, sorry, that part doesn't matter. That stays the same. It wasn't a negative. That is a negative, but it stays this way. And we can check that by just plugging in back a number that is greater than -7, so which is like 0. So you could plug 0 back in to the very beginning. And 0, that'd be 6 to the -5. And 0 in here would be 5. And that negative would be a fraction, right? So 5 is greater than some fraction, correct? So it actually stays this way. The only time it switches, if you're divided by a negative, this negative doesn't really matter though. If they were possibly both negative, then that might be a difference there, but you can always come back and check. So a lot of times I just pretend this is an equal sign, and then once I get my answer, then I just go check a number bigger than that or smaller than that and see which one works, and then I come back and adjust which sign it needs to be. But that is the correct answer.